Alright, hello guys. It's time to work on more functions. This time we're going to be working with the exponential and logarithmic functions. As you know, the standard notation of a function is f of x, and for any exponent it's b to the x power. Now, as we already know, b, if it's greater than 1, means that the graph will increase as it goes along x. However, if b is between 1 and 0, the graph will go down. This is called an exponential increase. This is an exponential decrease. Now, there are many things you can do with the exponential functions. For example, we've got the compound interest formula. If you've ever gotten a bank account, you know that your savings account will increase over time because of interest from the bank using your money and then them thanking you by giving a small percentage back with extra. So, first we have a principal, P, times the quantity of 1 plus a number n. Sorry, I think I'll choose R for this one, because this is going to be the rate at which your account will earn interest. K, which will be the number of times your account's going to compound on itself. Sometimes you're paid quarterly, which is every 4 months, or every 3 months. Sometimes you're paid semi-annually, which is every 6 months, and sometimes it's just annually, which is once a year. And then you put that to the k times t power, t being the amount of time, say after 18 years. So let's work on an example. Let's say you have $1,000 put into an account that gives a 7% interest rate and compounds quarterly. And let's say you check it after 20 years. So what would be the amount in your account? This is the balance of your account after 18 years. Well, that's 1,000 times the 1 plus the percentage 7 over 4, which is 1.0175 to the 1 times 20th power, or 4 times 20th power, or 80. So 1,000 times 1.0175 to the 80th power means that you will have $4,006.39 rounded to the nearest cent. So if you put in $1,000 at a 7% interest rate compounded 4 times a year, and you check back after 20 years, it will be $4,006.39. If you're given an account that compounds continuously, continuously is pretty much infinite if you go down small enough. So there's a different method of doing it. For continuous interest, it's your principal times the constant e, which is equal to 2 2.718 rounded. It goes on actually, just like just like pi. This one is also irrational and just continues on to infinity. So this is a shorter version of it. Anyway, back from the tangent. And then we put this to the k times t power. Remember? K is the... sorry. K is your amount of interest rate, and then t is your time. So let's say we do $1,000 at the same amount of time as all of the others. That means that 1,000 times e to the quantitative 7% times 20 power, which means you will have, after 20 years at a 7% interest rate, after putting in $1,000, $4,055.20. Why? Because it's a continuous gain of amount. It gains every single moment between that 20 years, instead of just every 3 months. And so that is the interest formula as used with the exponential functions.